So in my last Pymol video, I talked about how to use the .pml file to automate the figure you see on the left. Now we're going to be looking at how we can convert this to a Python file that we can run on any molecule. And as you can see on the right, this is a cytochrome P450, and the same script can be used on this as on this GFP and any other molecule you want. So in doing so, we'll learn proper practices for making functions, how to run them in the Pymol command line, and how to debug them. So let's get to Pymol. So here we are in Pymol. On the left-hand side, you'll see one EMA, and it has a selection, which I'll talk about in a second. In the last tutorial, we went through how to make a .pml file to make the image I showed just before. And this is the .pml file. You see these are basically Pymol commands. Now what we'd like to do is make that same image, but with a Python script. So I think it would be good to take a look at both of these scripts, a PML script and the Py script, side by side, just to get an idea of what goes into converting the two scripts. So here in the .pml script, we have the ray rendering settings, and then we have basically hiding the foreground. We're setting the view explicitly here, which we don't have to do in the Pymol script. And then we're taking a picture of the first PNG. Then we take a picture of the second PNG, or a third and the fourth. So again, this can only be done on one molecules, one EMA. We want to make this more applicable to other molecules. And so to do that, you go into Pymol. I'm going to start with you import Pymol. So from Pymol, import command. So this will give you access to the Pymol API. And util is another command. And then import OS for working with files and sys. These are both Python modules. Then usually set the global variables. So these are variables you can change here, and then they'll be propagated through the functions. If there's a lot of these, it's actually a good idea to have a separate file, like a settings.py file. But for this tutorial, we won't do that. So here you see the first function is def Pymol settings. So basically, it's just taking these settings, but they're wrapped in CMD commands. So cmd.set ray shadows. Instead of saying set ray trace or set ray shadows to 0, we say cmd.set ray shadows 0. So I'm going to go down a little further so you can see the organization. Usually in a Python script, there's a main function you call. It's actually usually called main, an if main function. And in usually if you run your script, this will automatically call that function, which will call everything else that you need. But in doing Python in Pymol, it kind of obscures it a little bit. You can't run that because you're basically in a namespace, Pymol namespace, inside of another namespace. So instead of running that, you'll run basically another command or another function that runs everything else. So we're going to do run selection. You can call it anything you want. I just called it run selection. So what it does is it runs the other functions. So here we have Pymol settings is run, and then it also takes the arguments in. So note that here, when you pass arguments to the command line in Pymol, it's always a string. So you have to split those strings into separate arguments. You can't do argparse or other parsing with Pymol, or you can, but it's very hard. It's not really worth it. So once you do this, then basically you're setting the active site to the last half of the argument, and then this is an argument that can be changed, and I'll talk about later the ligand color off. Basically, you can set it to the GUI ligand color. that's in the GUI or what you're actually setting in the global variables above. So here we're basically running protein active site. That's the select objects function. And then this will give you, it returns a protein in the active site. And these variables that you return will be used in other functions. So one thing you always have to do is use later if you want to test each function separately is cmd.extend. So it would be like select objects and then your function select objects. So we have function select objects. So we say cmd.extend select objects and then the function select objects. This just allows you to test it individually in Pymol. So what we're going to be calling when we call the whole script is the run selection. So the first thing I'm going to do is show you how to run the script. So here we get our one EMA molecule. Then we make a selection. So this will be the selection that we wish to hide. So maybe I'll just show spheres, just so you can see this. Show sticks. Okay, so now you can see the active site better. And we have our selection. To run the script, I just go to File, Run Script. And then navigate to it. So Pymol scripting lesson 3. Now, as you'll see, nothing actually happens when you run the script. This is similar to just importing a function in the Python namespace. So we have our script here, and we have our selection we made here. We're going to go to the main function, which is run selection. And we have, so this is also printed to the screen, but if you didn't know, you can look in the script and it has the syntax. So here we're going to type run selection, and we're going to do 1 EMA-A because that's the protein, and then 9A, oh, so that's a different one. 1 EMA active site residues, that's the active site, and 1 EMA organics. Organics. So these 3 objects are already here. EMA, 1 EMA residues, and 1 EMA organics. So we just run the script, and it should take a few seconds. And this is just the last picture that I printed out. But now we can go to our figures, and we should see we have 4 figures. So let's go there. So here we are in GIMP, and we're going to open those layers. We'll go in reverse order. So 4, 3, 2, 1, open. And you see we have nicely overlaid here. And if you want to export this, you can just say File, Export As, and you can export it as a PNG. So I want to show you a little bit more about like where it's saved. So if you don't put any or if you don't tell the script where to save it, it'll automatically determine your working directory. So let's see if you can get a better picture of this. Yeah, down here, basically it's saying this is where it's saved. So it's a Python script. So we'd like to try this with other PDBs as well. So here I have a complex with 2 ligands bridging them. And I've selected the residues which are kind of blocking the active site. So we've already run our script. So now, okay, so this is just saying that the last picture it took looked like this. So now again, we're going to head on over to GIMP. That you might notice is that both the ligands are green, which kind of makes it hard to see things. So we don't only have to have green, and so I'll show you how to change that in the command line. So we have 9AX6, and we'd like to color them so that the ligands are different colors. And to do that, all we need to do is set the ligand color off flag. So we do that, run selection protein 9AX6. So protein's up here, 9AX6 organics is here, 9AX6 active site residues is here, and then ligand color off is set here. So we run that, and it'll take a moment. And here we see the last figure that was printed out. And now we'll go and look at the overlay. So now we go into GIMP and we look at the overlay. Again, I just did File, Open as Layers, and then found the images. And they're ordered 1, 2, 3, 4. So this looks pretty good. We have a green ligand and a white ligand. And the rest of the protein is in black and white, and we have the yellow residues. So now we'll try this one more time with a cytochrome P450 that has a heme here in complex with the retinivir-like inhibitor. So I already have the selection made, so all I have to do is enter the command. So again, the command you can see here, run selection, 9-core A, 9-core A organics, 9-core active site residues, ligand, and ligand color off. So we'll get the same colors as we have in the GUI. So again, if we go into GIMP, we'll see once all the layers you see on the right here are overlaid, we'll get a nice image with the ligands colored as they were in the GUI.